My name is HASANI FITRI bin Hassan. My number metric is 212020668.
My name is DANISH bin KHAIRUL, and my matrix number is 21-2020-727. For the introductions, DC machines are separated into two types, which is DC generators and DC motors. The majority of DC machines are comparable to AC machines in that they include AC voltage and current. DC machines have DC outputs because their terminals feature a mechanism that converts AC voltage to DC voltage. DC machines are also known as commutating machines because electronic rectifiers provide direct current when it's needed. DC generators aren't as prevalent as they formerly were, because they could be supplied by existing direct current lightning power distribution network. DC motors were the first type of motor to become extensively employed. For the parts and design of the motor, we have brushes, DC motor commutator, armature windings, stator, poles, yoke, field windings, and rotor. Each one of the parts have their own function.
A DC motor is a type of electric motor that transforms electrical energy into mechanical energy. The DC motor's primary operating concept is that anytime a current carrying conductor enters the magnetic field, it is subjected to a magnetical force. An electric motor is a mechanism that transforms electrical energy into mechanical energy. When a current carrying conductor is put in a magnetic field, it experiences a mechanical force, says the basic operating principle of a DC motor. When armature windings are coupled to a DC source, the winding generates an electric current. Field winding, which is electromagnetism, or permanent magnets can be used to create a magnetic field. According to the above-mentioned concept, current carrying armature conductors are subjected to a force owing to the magnetic field. To create an indirectional torque, the commutator is split. Otherwise, the direction of force would have reversed every time the conductor's movement in the magnetic field was reversed. Types of DC motor. We have three types of DC motors, which is series DC motors. Series DC motors produce a lot of beginning torque, but they can't control their speed and can even be destroyed if they are not used. Because of these drawbacks, they aren't a viable choice for a variable speed drive applications. Number 2 is shunt DC motors. The field is linked in a parallel, which is shunt, with the armature windings in shunt DC motors. Because shunt field may be stimulated separately from the armature windings, these motors provide excellent speed regulations and easy reversing control. The third one is compound DC motors. Compound DC motors, like shunt DC motors, have a shunt field that is individually stimulated. Compound DC motors provide a high beginning torque, but in variable speed driving applications, they may have control issues. We will move on into DC motor speed control. We can manually regulate the speed of a DC motor or use an automated control system. This differs from speed regulations, which allows the speed to adjust to a natural variations in speed caused by a change in the load on the shaft. There are three DC motor speed control. Number 1 is influx control method. Number 2 is armature control method. Number 3 is voltage control method.
Starting method, the first one we have 3-point method. The starter in question is essentially a variable resistance separated into many portions. The contact points of these portions are referred to as studs, and they range off from off to run, with several resistance in between. This introduction has 3 important points, which is the first one is L line terminal, which is to be connected to positive of the supply. The second one, A to be connected to the armature winding, and F need to be connected to the field winding. The next one is the 4-point method. The connection of the no volt coil is the main distinction between the 3-point and 4-point beginning methods, NVC. NVC is linked in series with the field winding in the 3-point beginning technique, whereas in the 4-point starting method, NVC is connected independently across the supply through the fourth terminal and in addition to the L, F and A. So for the conclusion, a DC motor, also known as a direct current motor, is an electrical machine that converts electrical energy into mechanical energy by producing a direct current magnetic field. One of the advantages of DC motors over other types of motors is their ability to precisely adjust speed, which is essential for industrial machines. Two of the most significant benefits of DC motors over alternating current AC motors are their ease of installation and low maintenance requirements. A DC motor works on the principle that putting a current carrying wire in a magnetic field creates mechanical force. Because DC motors offer a higher starting torque than induction motors, they can be employed in an infinite variety of applications. That's all from us.
That's all. Thank you.